This is Heathrow Airport near London, and it's one of the busiest airports in the world. As a matter of fact, an aeroplane actually takes off here once every 60 seconds, and whilst one is taking off, others are getting ready to land. All that aeroplane activity causes a lot of problems because every single one of them has to be got up and down safely. As a matter of fact, aeroplane travel is the safest form of travel that there is. Safer by far than the daily journeys that we make by car or by bus. So, what is it that makes it so safe?
Speedbird 174 is now leaving Ockham, turning onto heading 060, maintaining flight level 80.
Roger 174, report leaving Ockham, heading 060.
What's your speed at the moment?
190 knots.
174, maintain 190 knots, descend to flight level 70, report leaving it.
Maintain 190, we understand. Kilo and confirming 740.
You're listening to part of the conversation between a British Airways pilot approaching Heathrow and the air traffic controller on the ground.
Speedbird 174, descend to 3,000 feet, QNH 1020.
Clear to 3,000 feet, 1020, Speedbird 174.
The controller is giving precise instructions to bring the aircraft safely to land on one of the Heathrow runways.
Speedbird 174, continue turning left, heading 320, closing the localizer from the left. Report when established, 28 left.
Speedbird 174 is established, 28 left.
Correct 174, 15 miles from touchdown.
Speedbird 174. Flaps 20, please. Thank you, sir.
Speedbird 174, 8 miles from touchdown now. Continue on the ILS. Contact the tower 118.7.
Heathrow Tower, Speedbird 174 is established on localizer and glide slope 28 left. Continue.
And that's another one safely landed. And this is Ian Cully, the air traffic controller who was responsible for bringing that aircraft into land. Ian, all that conversation sounded a little bit like a code to me. I didn't really understand any of it. Can you tell me what you were talking about?
Yes, certainly, Max. Well, air traffic control is like many other things which, to people that don't know what it's about, it sounds a very, very complicated system. But once it's been explained a little bit, I think you'll agree that it's not so complicated after all. Well, we've got the airport in the centre of the screen here, a little black hole, and round about we've got the various stacks. One here, one here, one here, and one down here. These parallel lines here are the guidelines to the runways, and the little clusters of letters and numbers represent the aeroplanes. There's one here, one down here, and one down here.
Ian explained that all the aircraft approaching Heathrow are directed to one of a number of stacks some miles away from the airport itself. A stack is part of the sky where planes are made to circle and wait. Below in the stack will be a number of aircraft also circling, but there will be at least 1,000 feet between each plane, so that there is no chance of an accident. When there's room at Heathrow, the aircraft at the bottom of the stack is directed to the airport and the vacant runway. But it can't fly closer than 5 miles to an aircraft making a similar approach.
In the system that we use here at Heathrow, it's my job to actually steer all the aeroplanes coming in around the sky until they're actually pointing towards the airport. Once I've done that, then control of the aircraft is transferred from me in the radar room to another controller who works upstairs in the glass house.
Somebody else takes over.
That's right, yes.
GP 450, Sabina 605, 357 the Speedbird, Shuttle 5B.
This is the Heathrow control tower. On the labels in front of him, the controller has details of all the aircraft landing, taking off, or taxiing around the airfield.
Speedbird 287, you're clear takeoff, 28 left.
This is a Boeing 747B. It's an American-built plane that's usually called the Jumbo Jet. It's used by British Airways to fly the long distances to America, the Far East, and Australia. In the spaces under the fuselage floor and inside the wings is carried all that will be required during the flight. Fuel, baggage, and the technical requirements for the aircraft and its controls. Inside the aircraft, the designer has found room for around 400 passengers and 16 cabin crew. And those passengers will need to move around, to go to sleep, or perhaps to watch a movie. To fit all these requirements into such a small space, passengers with their luggage, food, drink, the cargo, fuel, and technical equipment is a massive design task. And there is one other requirement as well: safety. Within this aircraft is all the equipment needed in the case of an emergency, and British Airways trains its cabin staff to supervise an evacuation in the unlikely event of an accident.
Ladies and gentlemen, we shall shortly be taking off. Will you please ensure your table is stowed, your seat back is in the upright position with armrests down, and fasten your seat belts ready for takeoff.
Ladies and gentlemen, we're cleared for takeoff. Will cabin crew please be seated?
Anybody else? Go on. Hold your hands against your body. Come on, come on.
How would you position the seats in an aircraft so that the passengers could get out as quickly as possible? Well, here's one way.
we've just come out of the aircraft there. Has anyone got any suggestions to make about how we could possibly improve what happened that time? Christopher?
We were pushing too much.
Yes, there's too much pushing.
People kept coming from each side instead of the people who were further away from the aisle clambering over all the other chairs.
Good point, good point. Perhaps we can try that.
The chairs were getting knocked away and they were blocking the aisle. And people kept on tripping over and that wasted time.
So it's important that the chairs don't get knocked over? Yes, good point. So we could perhaps try and get the people, the passengers, to not panic at the beginning and be more orderly in their exit. Has anyone got any other suggestions how we could possibly improve what happened that time? Benjamin?
Have 2 gaps.
2 gaps?
2 exits.
2 exits. Well, that's a possibility, I suppose. Where would you suggest we put the other exit?
Or somewhere in the back, so then the back half can get out one way and the front can get out the other way.
Right. Perhaps we could have the first row leave the aeroplane first, followed by the second row, right the way to the back, so that we don't have this pushing in the aisle. And we could also try putting the aisle in the center this time, so that people could come from both sides into it rather than having to move right across the side to come down. Perhaps we'll try that now. Right?
Your school will have plans for you to get out as quickly as possible in the case of fire. Do you know what that route is? Is it the quickest route? And what happens if one of the exits is blocked?
Time was that? 57 seconds.
That's what these young scientists are trying to find out.